Hey, what is up guys, welcome to a chess game tutorial. We will need Unity and also some assets. You could be using your own or simple shapes if you wish, like rectangles with different color for different pieces, but I will be using a pack I've got off the assets tool. Actually this pack over here. So it's pretty much just a high quality chess and checker set that I've got for about 12 bucks. You can find the link in the description below if you wish, and let's get started. So the first part of this tutorial is going to be all about creating a chessboard. We're going to draw some debug just to see the lines, the square, the tiles, and also we're going to spawn all of our chess pieces. So in order to do that, I will go ahead and just start off by creating a empty game object. So I'll go up here, create empty, and I will call this chessboard. Now make sure the position of that chessboard is at the origin, because we're going to be like centering all our tiles around the origin. Now maybe give it a icon as well, so say a blue one, and here is our chessboard. Now I will go ahead and do add component, and we are going to start scripting. So the first script, I will call it board manager, just like this, and let's open it up inside of MonoDevelop. Okay, so I'm going to zoom in on that a little bit, and let's declare a few things we are going to need. So we have to decide on a metric for our game. So how big are going to be the tiles? How big are we going to just put our whole chess game into? And what I was thinking is using some private const. So up here I'll do private const float, and I'll do tile size, and let's say that every single tile is 1 meter by 1 meter, because that's really easy to calculate. Now let's also create another one, so private const float tile offset, and that's the offset to the center, so it's pretty much just always tile size divided by 2. What else could we be using? We could be using the current selection, so we're going to be having a mechanic where you mouse over a tile and that tile glows. So we also need to keep track of which tile we're selecting right now, so maybe a private int selection x, and we'll set it to -1 when nothing is selected. Next, private int selection y is equal to -1 as well. Okay, so all of these are cool, but we don't really know what we're doing with that just yet. So the first step would be to start visualizing our board a little bit. So what I'll do is go down here and create a private void update. And inside of that update, we are going to call another function that we haven't made just yet. It is going to be the function, actually let's go ahead and make it, it's going to be the function draw chessboard, like this. Now in the final build, we are not going to be using this, we're going to be using our own assets. But right now I just want to have a quick preview of what the tiles are going to look like. So it's fairly simple, at the same time it's a little bit complicated, but if you just follow along, I bet you're gonna get it quite fast. I'm going to start by declaring a vector tree that I call width line, which is pretty much just going to be vector tree dot right times 8. Now what is this exactly? This is a unitary vector, so of length 1, that is pointing towards the right. We know that every single tile is 1 meter, and this is also 1 meter, so that's going to work for a single tile. And then we do times 8, because we got 8 tiles on a chess game. I will also declare another one for width, so vector 3 height line, like this. And this is going to be vector 3 forward times 8. Okay, so we've got those two vectors. Now we need to draw them 8 times in each axis, actually 9 times, because we need to close it as well. So what we'll do is we're going to use a simple for loop, so int I is equal to 0, as long as I is smaller than 9, or let's just say smaller and or equal to 8. Then we do I++, like that. And inside of that inside of that for, Let's have another for loop, the same one, but we're going to replace all the I for G, or J, sorry. So the call we're going to be using is called debug.drawLine, but this one takes in two vector in parameters, so we have the start and we also have the end. Now what we need to do is find a start point for every single one of those lines and just add the width line or the height line depending on which function we are. So I'll just leave this here temporarily and I'll go ahead and just declare myself a vector3 that I'll call start, and this is going to be vector3 forward times I. Let's actually test this out. So we're going to do draw line start, and then we'll do start plus I think this is width line, like so. Okay, let's just try it out really quickly so we have a nice preview of what's going on. So we're going to go back in the game, choose your chessboard, make sure that the board manager is on there, and then if we click play, we should be able to see something of the sort. So that's only for the width, and it makes sense. Let's count really quick. So that's 1, 2, 3, 4, 5, 6, 7, and 8 square. And on this side, 1, 2, 3, 4, 5, 6, 7, and 8. Okay, so let's go ahead and close this off in this draw line over here. We're going to be copying this, and let's reuse the same vector to save a little bit of memory. And let's change vector3.forward for vector3.right times J. J. There we go. Now we should be good to go. Oh wait, we forget something. So start plus height line instead. And this should actually already draw us a nice chessboard board game. Right. So this is it. What is the next step we could be taking? We could be doing the selection already. So yeah, let's go ahead and do that. What we're going to do now is we are going to update the selection. So somewhere over here in our code, we need to update every single frame the selection using the camera and also our mouse position. So I will create a new function that I'll call update selection, and I'll just go ahead and drop it inside the update as well right here. And let's actually update first and then draw. Okay, so basically what we're going to be doing in this is asking, is there a camera that we can use to test this out? If there's not, we're just simply going to return. So let's do that. If camera.main, we're going to be using the main camera. If there is no camera.main, then let's simply return out of this function. And then after that, we are going to declare a raycast hit, which is going to be a type we're going to be using if we hit something. And after that, we're going to do the famous camera screen point to ray. So inside of a if statement, let's do physics.raycast, and then we got to give him a ray, and that's where the camera comes in. So we're gonna do camera.main screen point to ray, which is going to return us a ray going from the camera to the position we give it, and the position we're gonna give it is input.mouse position. Now that's really complicated if we just take a look at that, but eventually you're going to start understanding why we do that. And next, what do we need to give it? We need to give it a out info. So we're going to say out hit. So if it does hit something, we're going to get the result back of that collision inside of a of this field over here. Okay, and then we could give it a max distance as well. I'm going to put 50. It could be less than that, could be maybe even 25. It doesn't have to be that long. And finally, we got to give it a layer mask, because we do not want this ray that we cast from the camera to our mouse to actually hit a chess piece. We only want it to hit the chessboard. But now, what exactly is that chessboard? We don't even have one yet. I mean, we draw some lines, but they don't actually have collision, and you know, they're not going to be there in the end game. So what I feel like doing really quickly is I will put this in comments, just this line, so we can compile and have a look at the game. And let's hit play on that. As you can see, this is it. This is our board. We cannot select it. It's not an actual object. So what I'd like to do is go under chessboard, and we are going to create a new plane. So new 3D object, plane, and then I'll move it as a children of the chessboard. I'll simply go ahead and rename it chess plane and move it at the origin of the world. Okay, so now our plan is to make sure that this plane actually matches our checker. Now if we do move it over here, I don't know if you can tell, but this is still a little bit too big, because this is 10 by 10 and this is 8 by 8. So basically what we need to do is scale down this plane to 0.8 on all of the axes. Now it is going to assume the exact same size, as you can tell, and we can simply move it over there. So that's what I will be doing. I'm going to use the move tool, so that's W on the keyboard, and then hold Control while moving this around and snap it right next to the origin, like so. And let's go ahead and save the scene while we're at it. So this is going to be the chess game scene. And now if we hit play, this plane now assumes the same exact size as the other one. But I don't really want to have the mesh renderer. I only want to be using this for the collisions. Okay, so now we know that the plane assumes the same size as this. And if we take a look at the collider now, if we turn off the mesh renderer, if we take a look at the collider, as you can tell, it is not really optimal, and there's way too many vertices on that compared to what it really needs. So what I will do is, you are going to leave the mesh renderer off, but you leave it on the object. We are going to remove the mesh collider and then add a box collider, so it looks something of the sort now. And if we press play, it still assumes the same size, it is still the same exact thing, but we only have a box collider now, and we don't have the whole thing. And if we just scale it up so we can see, as you can tell, it's pretty much just perfect pixel. And okay, so that's really more optimal than what we had. And we now have a chess plane. Now let's go ahead and use that chess plane to actually test out some collision. The first thing we'll need is to change the layer of this. We'll need our own layer, so we can test our raycast only against this layer and nothing else on the map. So I will go over here in layer, do add layer, and this is going to be the chess plane. Now copy this text, make sure that the chess plane has the chess plane layer on, and we will head over to our code and finish our line. So we said, well, right now it only needs a int that is the layer mask. We will do layer dot get mask and send that chess plane as the parameter, just like this. And this is going to return us the appropriate int. Okay. Now, since this is a if statement, we are going to open up the curly brace. And if we manage to hit something with our screen point array, then we should actually take action. Okay, so if we do hit something, let's have a look at what we can actually use. So if you remember correctly, when we hit the raycast and we give it a out parameter, it puts the information of that collision inside of the out parameter, so we can actually use it later on. So if we hit something, let's do hit dot, and then we have a lot of information, so we could take the collider off what was hit, or we can take the distance, but what we're really interested in right now is the point. So where exactly did the collision happen? So let's just go have a look in the game of what this gives us. I'm going to press play, And now if I mouse over this, nothing is going to happen. I actually need to use the game camera. And I don't know if you can tell, I'm getting some result down there, but I think we're gonna have to move the camera a little bit. So let's go ahead and just do that. I'm going to put the camera at the center of the world. Now I know that my chess game is all opening around here. So let's go ahead and try to center that. So maybe to position 5 in X and move it backward like so. So 5 in X, minus 5 in Z. And I'll just crank it up here, rotate it downward. And let's have a look. This is our result. Okay, so maybe forget about the 5s. Let's go ahead and put some 4 instead. Okay, let's press play. And this is the result we get. Now, if I mouse over the first tile over here, we get 0.400 and then 0.2. As soon as I cross that first X, then we know we're 1 meter after X, and it just keeps going like that. So we can actually use this to know which tile we're on. So at the end over here, we're at 7.5 and 7.7. If we actually truncate that using a cast to int, we actually know which selection we're on. So what I'll do is go over here and do selection x is equal to, and then truncate that to int, hit dot point dot x, as simple as that. And then selection y is equal to int, hit dot point dot z. Now make sure this is z and not y. Okay, and say we're not actually hitting anything, then what we should do is reset those two values back to -1. So let's go ahead and do that. I will create a else statement, and I'll do selection x is equal to -1, and selection y is also equal to -1. Okay, now we pretty much have all we want, and we think that the selection is going to work. Let's actually test it out in our drawing function. So over here we draw both horizontal and vertical line. Let's go a little bit below that, and we will draw the selection. Now this one is going to be a little bit more complicated. You have to really be able to place yourself in the 3D space. So if selection x is bigger or equal to 0, and let's also do if selection y is bigger or equal than 0, then if that's the case, that means we have something selected right now. So what we'll do is debug.draw line, and the first one we're going to draw is going to be a vector3 dot forward times the selection in y plus vector3 plus vector3 dot right times selection z. So that's the start point, and then as for the end point, we gotta give it some kind of diagonal. So I'll be doing vector3 forward times, and then open the parentheses, do selection y again, plus 1 this time, and then we'll do plus vector3 dot right times, and we open up the parentheses again, selection x plus 1, like so. Now I will go ahead and just take a look at this in the game and mouse over some tiles, and this is the kind of result we get. Let's actually add another line so we can have some kind of cross on top of the tile. So I will quickly go ahead and just copy this code. So Control-C, Control-V, and over here we will put that in parentheses instead, like so. We don't actually need anything more here. Let's remove this one. Since we want to go in diagonal down, this is going to work, I believe. Let's actually try it out. And let's do plus. There we go. So this is the kind of result we get when we select something. Now if we release a selection everything is gone and we don't see that little X. So we have a really good start now, and I think that we're ready to actually spawn all the chess pieces. So let's go ahead and do that. We are going to go up here and declare ourselves an array of prefab we can use to actually spawn those. So I will do, oh, never mind. First off, let's include system.collection.generic so we can use list. And then after that, I will declare a public list of game object that I call chess pieces. Actually, let's call them chessman. It's another name for a chess piece. So chessman prefabs, like so. Now this is going to be only for the prefab at the moment we actually instantiate them. Let's actually create another list of game objects that are going to be for the one that are actually active right now. So I'll do private list of game object, and I'll do active chessman, like so. And then we need to go ahead and just fill both of these. So if we select our chessboard, we can now see that we have a new field over here that we can configure. Now, based off the asset I've downloaded, we can tell that there is a total of 12 pieces. Now, of course, there is more on the board. We actually reuse the same piece sometimes as the pound. We use it 8 times. So we are going to need an array of 12 actually. Now the next part is all about dragging these inside of the elements just like so. But the only thing is that we don't really have any control over these, so what I'll do before that is actually create some prefab out of those. So I'm going to just drag and drop one, make sure that it makes sense. And to me right now this is way too small. As you can tell, it doesn't really look that good if it's that small. So what we will be doing is I'm going to delete this one, and not before, but actually right here in the artwork folder, I'll take all of the objects, including the chessboard, and I will scale them up by 10, because right now I think they're pretty much made to be 1 decimeter by 1 decimeter. So I'm going to take all of them, change the scale factor to 10, and then hit apply. The reason I'm doing that is because my tiles are 1 by 1 and not 0.1 by 0.1. Let's actually try now, just drag something, and as you can tell, this makes way more sense. And here it is in a game concept. Okay, now we still don't really have any controls over them if we just simply drag and drop them inside of the element array like that. What we need to do is actually create prefab out of those beforehand. So I will just grab all of these, unselect the chessboard by hitting Control and then clicking on it, and drag them inside of my game. And here they are. I think they're also missing the texture, which is fine. We'll just go ahead and apply them. So right here we have the White King, and that's going to be the first one. So let's actually take it and drag and drop it inside of the project folder. So right now we have a White King. We have the White King prefab, and let's actually find the texture for this guy. Here it is. So that's a White King over here. Okay, so now that's one of them. I'll go ahead and just keep on doing all of those. Create a prefab folder to just store them somewhere. And while I'm at it, I'm also going to create a script folder, drop my board manager in there, and also a scenes folder. There we go. And we're simply going to keep on going. So I've got the White King done already. I'm going to delete it, move to the White Bishop, and we are going to move it around here so we can have a look. Let's change the texture for Bishop White. There it is. Drag and drop it inside of the prefab folder. Then let's get rid of it. White Knight, same thing. So Knight, oh, I actually got the wrong texture on the king, I think. Yeah, I was using the knight one. Actually going to use a king. And let's keep going until all of these are pretty much completed. So here we are. And then the king, queen. Okay, so the first side is done. Let's keep on going with the other ones. So where are the black pawn? Here it is. Then delete this one. Here is the queen. So you pretty much get the picture now. We gotta do this with every single pieces. And there's also other texture in case you want to be using some more, like normal mapping and occlusion mapping, I think. Is that what I saw? I think there's also occlusion map. You could be adding that as well, but I'm not going to take you through that because it's a little bit redundant, to be honest. And we are almost done, so that's the knight, and then drop it here, and finally the black bishop. Okay, good. So once we got all of these as prefab, we can go ahead and just add them to our element array that we made here, so game object array. Now I'm going to add all of the white one and then after that all the black ones, but we're going to do it in a certain order that we can remember. So the first one, let's just assume is going to be the king. So the white king, and then the white queen, and then let's do the rook. So white rook, white bishop, and let's do knights, and finally white pawn. And then we do the black one but in the same order, so black king, black queen, black rook, black bishop, and knight, and finally pawn. Okay, good. So let's go ahead and just save that, make sure we don't lose this progress, and we are going to go back inside of our code. So I'm going to double click on board manager and go inside of here. We are going to create a new function. So somewhere in your code, doesn't really matter where, we're going to declare a private void that we're going to call spawn chessman, like so. And then we're going to need something else. We're also going to need which index we're using from the chessman prefab. So let's do int index, and also the position in the world we're going to be spawning it. So vector3 position, like this. And then what we will be doing is declaring a temporary game object. So game object go is equal to instantiate, and then we're gonna instantiate chessman prefab at the index. Then we're gonna give it the position, and then finally quaternion.identity, which I believe is going to work, else we're going to have to declare our own quaternion. And finally cast it as a game object, just like this. Okay, so the next line is all about changing the transform, because right now if we actually run this, it is going to create a object somewhere in here, and it's pretty much going to get really messy in the scene. So what I'll do, just for the sake of having it clear, is I'll do go.transform.setParent, and we're going to be using our own transform as a parent. And finally add it to our list that we've made a little bit earlier. We would do ActiveChessman.add, and we will add geo like this. Okay, and we're also going to make sure that this list is instantiated. So up here, only for the ActiveChessman list, do a is equal to a new list of game object. This way we don't get a null reference. Let's actually test this out inside of a private void start. So I'll go up here, do a private void start, and we'll do spawn chessman, spawn me, say the white king, so that's index 0, at position vector3.0. like so. We are going to hit play, and it pretty much just spawned the white king at the position 0, and he is now under the chessboard. So if we move the whole chessboard, the king moves with it. Now, of course, the deblock.draw rate, they don't, but they're not always going to be there. Alright, so now that we've got this, what could we be tackling? Are we going to tackle the whole thing? Let's actually start by trying to position this somewhere. So, the white king, we know he has to be around, I think it's the 4th tile. So he should be around here usually. Just move him by himself. So how exactly are we going to get this position? Now, I was thinking about making a helper function that would actually help us get the exact position of this tile, and then we can use that when we spawn them, and also later on when we move them. So that's actually not a bad idea. Let's go ahead and do that. We are going to go inside of our code, and just going to close this up. We're going to create a private vector tree, and let's call this get tile center. Now get tile center is going to take in a int x and also a int y to give it, okay, which position are you on right now on the board. And we're gonna do vector3, and we could call this one origin, which is pretty much just the origin of your board. In our case, it's 0, 0, 0, so I can set it to vector3 0 like so, and then we'll do origin dot z is going to plus equal the tile size, so we know that's 1, times x. So say if we are on tile number 1, you know how the index works, so that's 0, 1, 2, 3, 4, 5, 6, 7. We never reach 8, so we're 0 base. So say we're on tile 1, that's the second one, that it does 1 times 1. And we gotta add another little offset to that, so that's the tile offset we were talking about earlier. So I'll do plus tile offset like this, and then origin dot y plus equal tile size times y plus tile offset again. Okay, so if y is 0, then this is 0 plus the tile offset, so plus 0.5. Good, and then finally let's go ahead and just return that vector that we calculated. Okay, now back in our start, we are going to change that vector 3.0 for get tile center, and you're gonna get me the what was it? That was the 4th tile, so it has to be index number 3. And then as for the y, this is going to be 0 because it's on the first actual line or row. Okay, let's play. And there we go, it is positioned at the right place. Now I believe there's a small offset that is not really cool. Actually, it's quite bad. Let's see why. Okay, so small mistake on my part. Instead of using the z as I should be using when I move that, I'm actually moving on the y-axis. So you see over here where it says 0.5, this should be on 0, and z should be on 0.5. Now this is centered, but in our code, we do it in a kind of reverse way. So what I'll do is over here where it says origin.y, instead of that we'll do origin.z, and then we should be fine. Okay, test this out once more, and there it is. That's the king at its correct position. Alright, so now we're spawning one, but we got quite a lot more to spawn, so what I feel like doing is actually creating another function for that, just to remain clean in our code. We will do a private void, and I call that spawn all chessmans, like this. This is going to take no parameter, and it's only pretty much going to be called at the beginning of a game. So, inside of spawn all chessmen, I'll actually just go ahead and do active chessman is equal to a new list of game object, and I'll remove it from up here because I don't really like having it up here and we know that this is only going to be called once. So let's put it in the spawn all chessman. After that, we're going to spawn the white team. Let's start with a king. So king is going to be, actually we already have the king, so I'll take this line, cut it, and I will do a paste down here. So the king is covered. Now let's go ahead and just copy this. This is going to be the queen. Now the queen is at index 1, and the tile you need is actually the 5th one, so 0 base, this is full. After that, let's go ahead and move on. This is the rooks, so we're going to need 2 of those. It is at the index 0. We spawn one at 0, 0, and then the other one is being spawned at 7, like so. Let's copy this again. Let's do bishop. This is the prefab at the index number 3. And we're spawning one at, I believe it's the 3rd, so that's 2, and then the 6, that's 5. Finally, not finally, I mean next one is knights, and the knights are at the index 4, and as for the tiles, they are on 1 and on 6, and finally the pound. So we've got 8 of those to do, so instead of writing 8 lines like that, let's actually do a for loop. So we'll do for int I is equal to 0, I is smaller than 8, then I++, like so, and we'll do spawn chessman, and it will spawn the one at the index 5, get tile center, and this is going to be I and 1, because we're on the 2nd row now. Good. Let's go ahead and just have a look at this. And the board is empty because we forgot to call the function, so I'll go ahead and just put it in the start, like so. And then we should get a result. And here we go, let's have a look. So everything looks pretty much perfect except the orientation of the horses. Now the horses is really the only one that really needs orientation, but I think we're going to be applying it to every single one of them. So what I will be doing is up here, I will declare a private quaternion, because we need quaternion for rotation, that I'll call orientation, and it's going to be a new quaternion. Actually, don't put the new statement, just quaternion.euler 0, 180, and then 0. And I will be replacing it in the spawn chessman function. So you see over here the quaternion.identity we put. Let's replace it by orientation. And press play. We should be having pretty much working now. And yep, there we go. So that's a very good start. Let's go ahead and duplicate the whole thing. So all of this to do the black team. Okay, so spawn the black team. Now the king is at index number 6, and I believe that we can just leave all of these values as for x, but the y are going to be 7 in this case. So spawning this at 3, 7. Now the queen is index number 7, and then, like I said, we put dy on 7. Same thing here, 7, 7. I'm quickly going to change all of them so we don't have to deal with that later. And then as for the pounds, these are going to be 6. Okay. So queen is index number 7, rooks are index number 8, bishop index number 9, knights are 10, and finally pawns are 11. And we should already have something working right here. Let's press play. And here we go. So that's a very nice start for our chess tutorial, and I think we're gonna end this here. We covered quite a lot, and we already have some nice visual. So I will end on this note, and in the next episode we're gonna tackle the movement of these and the turn base. So guys, thanks a lot for watching. If you have any question or comment, please leave them in the comment section below. If this video helped or if you enjoyed it, please leave it a like, and I will be seeing you next time.